So we're taking a look at how to solve this kind of problem. Now, we're going to start by taking a look at an algebraic approach, because that's going to be our main focus today, is the algebra about how to solve these. Because we've done it by graphing, but we also need to be able to do it with some algebra as well, because it's going to be more efficient in many cases. Plus, it lets us get more exact answers when they aren't nice, pretty whole numbers. All right, so when you see something like this with the x squared in there, and notice it's just an x squared, there's not an x squared and an x. We'll deal with those differently. The first thing we want to do is get the x squared by itself. So, of course, in this case, that would mean adding 1 to both sides of the equation. So we go ahead and do that. Add 1 to both sides. Then, having done that, we need to get rid of the squared. Now, what undoes a square? Square root, exactly. So we're going to take the square root of both sides of this equation. And so, generally then, this is what most people are going to do. We're going to do the square root of sides. We end up getting x equals 3. Great, looks good. Makes sense even, because if I take that 3 and plug it back in up here, there we go. 3 squared is 9, 9 minus 1 is 8. So yes, that works. But remember, we've also been able to solve this by graphing. If we were to approach this that way and actually solve this by graphing, remember that means I'd take it as y equals x squared minus 1 and y equals 8, and I'd graph both of those on the same set of axes. And this is what I'd end up with. But notice that by doing it that way, I actually end up with 2 answers. I end up finding, yes, x equals 3, that's the one I just found, but we also find x equals negative 3. And that could be a potential issue, because whichever method we use to solve it, we should end up with the exact same answer. So then, why did we find that x equals 3 but not that x equals negative 3? It's actually because we need to add a layer to our algebra. So there is a new rule that we need to add into our process here. When taking the square root of both sides of an equation, we must account for both the positive and the negative square roots of that. And so then our work is going to change a little bit. Instead of just square root of 9 x equals 3, what we do is we write plus or minus square root of 9. When you see that plus or minus, it actually means both the positive and negative versions of that number. So when you see x equals plus or minus 3, what that really means is x equals 3 and x equals negative 3. And so then this is how we'd actually present our answer. We'd say then x equals 3, comma, negative 3. Now that does mean the exact same thing as the plus or minus 3, but for reasons that we're going to be encountering later in today's lesson, I'd rather you be writing it as 2 separate numbers rather than just the plus or minus 3, even though they mean the same thing, just because it's going to allow us to work with them a little bit more later. So, new piece to our algebra today: when we take the square root of both sides, you introduce a plus or minus in front of that square root. And again, actually let's go back and see why. Remember earlier I plugged 3 in for x? Notice if I plug negative 3 in for x up there, negative 3 squared, of course, is 9. A positive 9, because a negative times a negative is positive. And so 9 minus 1 is still going to give us 8. All right, so with that in mind, we're now going to go through seeing how to solve this one. Now you know basically the whole process. The key is start by getting the x squared by itself on the left-hand side. All right, so let's actually take a look at how we would go about doing that. So first thing I want to do is get the x squared by itself. That means I got to get rid of the 5 and the 7. Well, technically you could start by dividing both sides by 5. Remember, you'd actually have to divide everything on both sides by 5, including the 7. Yes, you can do that, but it tends to create messy fractions, and it's just a bit harder. So that's why I always suggest getting rid of the addition and subtraction first. If you do that, this is what your work's going to look like just to get the x squared by itself. We then need to get rid of the squared, which of course means doing the square root of both sides. When you do that, let's focus on some details. I write the square root over both sides at this point, and when I do that, when I write the square root, that's when I write the plus or minus in. It needs to go in with the square root, and it only goes on the side that's just the number. I don't need to write it in front of the x squared part. Basically, our pluses and minuses will just cancel each other out. We don't need to worry about that. So just write that plus or minus in front of the number part, which in this case is the right-hand side. So we get x equals plus or minus 3 again, so x equals 3 and negative 3. All right, so having done the x squared equations, the quadratic equations, there's another equation we've been working with all year that when we go to solve it algebraically ends up feeling very similar. It's got a few of the same tricks in it, and that's absolute value. So go ahead and write down this equation. And in this case, I want to start by getting the absolute value by itself. Just like I wanted to get the squared by itself, I want to get the absolute value by itself here. So that means getting rid of the 3, so I'm going to go ahead and subtract 3 from both sides. I then have that the absolute value of x equals 7. All right, and then this one ends up being a little bit similar to the x squared at this point, because I now need to get rid of those absolute value bars. Well, the absolute value of what would equal 7? 7. Yeah, so I know then that x could equal 7. But the absolute value of what else? Yep, negative 7. So you'll notice that in order to get rid of absolute value bars, we end up having to put in another plus or minus. So in order to undo absolute value, we again must account for both the positive and negative solutions, because the absolute value of a positive and a negative number give us the same thing. And yes, this would be your complete answer for this one, x equals negative 7 and 7. So, having seen the ones we've done so far, I think you got the process for how to go ahead and solve this one. So please go ahead and solve this one out on your own, and then we'll check in here in a moment, see how that's going. And so again, our first step is get the absolute value by itself. So add 4, divide by 6, then we have the absolute value of x equals 4. Now if the absolute value of x is equal to 4, then that means that x could equal both positive and a negative 4. So that then is our final answer. X equals negative 4 and 4. Now, so far, all of the answers that we've seen are always plus or minus the same number. But sometimes when we solve these, that won't be the case. And so we're going to go ahead and start by taking a look at those with this problem here. The absolute value of x plus 5 equals 9. Write that one down, of course. Then we'll go through it. Now, when solving this one, first of all, what can't we do? We cannot start this problem by subtracting 5 from both sides. That plus 5, it's trapped inside of the absolute value. That absolute value is doing something to it. So I can't just pull that out. So instead, I'm actually going to have to deal with the outermost part of the function there on the left side, which is the absolute value. So in order to undo absolute value, that means I get both the plus and the minus. So really we're looking at something where x plus 5 could equal a positive 9, or if x plus 5 equaled negative 9, the absolute value would still give me 9. So that's why it's plus or minus 9. But the problem now is that the way we've written it is a little bit clunky. Because if I now go to subtract 5 from both sides, which yes, I'm allowed to do, how would I do plus or minus 9 minus 5? It should be two different numbers, because remember, plus or minus 9 represents 9 and negative 9. So, in order to make this process easier, I'm actually going to split it up into two separate equations. I do x plus 5 equals 9, and separately x plus 5 equals negative 9. That way, when I go to then solve it, I'm not having to figure out how do I operate on plus or minus 9. I'm just operating on 9 and operating on negative 9, each individually. And so you'll notice we get two different answers here. Again, not the same number. X equals 4 and negative 14. And a side note on this, when you go to enter your answers into WALMAP, usually we'll just list them out. Like you'll tend to see something that looks like that, x equals, and then the box where you type in your answers. If this was my answer, I'd just go 4, negative 14. We just list them out like that. If you're doing it in WALMAP and it's the same number, like let's say it was plus or minus 4, you'd have to again list it out. You can't actually use the plus or minus symbol in WALMAP. You just list both numbers separately. Alright, so having seen those, you should be able to then solve this one. Same process. Get the absolute value first by itself, then get rid of it from there. Alright, so first up, you're getting the absolute value by itself. So make sure you got to this point. And then once we've gotten here, this is the point where I have to get rid of the absolute value. Now remember, getting rid of the absolute value means splitting it up into two different equations. So I have one of them where it's a positive 6 equals x minus 9, and the other one where it's a negative 6 equals x minus 9. Now a note before we finish these off. At this point, one particular error can creep in if we aren't really careful about it. Notice which number becomes plus or minus. Which one do we flip the sign on? It's always the number that was by itself on the other side. You'll notice that the minus 9 that was inside of the absolute value, that part didn't change. If it's x minus 9 inside, it stays x minus 9 after we get rid of the absolute value as well. We do not make that a plus or minus. It is only the number that's by itself. Alright, so now we've gotten to this point, we can go ahead and finish solving it out. And so, we add 9 to both sides of both of our equations, and you should end up with the answers of 15 and 3. Alright, so then we start with quadratics, then we went to absolute values, now we're coming back to quadratics, because now we're going to see how the quadratics work when they have something on the inside as well. And so we're solving a quadratic, right? We saw earlier, in order to get rid of the squared, we do square root of both sides. That doesn't change. Because the squared is the outermost part of the equation, that's what I'm doing first. Now remember that when we introduce the square root, make sure you got that plus or minus written in front of the square root. As soon as you write a square root symbol, you're writing the plus or minus on the same line. Now, when we do that, on the right side here, when we do the square root of x plus 5 squared, remember that the whole reason for doing the square root is it cancels out the squared. So that's just going to leave us with the x plus the 5. But on the left side, it equals plus or minus 3. And you notice I'm going to have to be operating on that 3 in order to get rid of the 5. So because I have to operate on it, I definitely want to write that as two separate equations here. So I do 3 equals x plus 5 and negative 3 equals x plus 5. And again, the x plus 5 stays in x plus 5. The stuff that was inside with the x, we didn't change that sign. And so then we finish solving it out from here. So we subtract 5 from both sides in both equations. And you end up with x equals negative 2 and negative 8.